Alright, welcome back. This is video 2.2. We're going to be talking about scientific notation and about the metric system. So scientific notation is something that you hopefully know about from your math classes. But remember that scientific notation, it can be used to express any number, no matter how big or how small, as a number between 1 and 10, multiplied by a number raised to a power. So the big number is called a coefficient, and the little number is the power is the exponent. So you count the number of places between the decimal point and where it needs to be to give a coefficient between 1 and 10. So if I have a number that is written in scientific notation, so 2.4 times 10 to the negative 2. What this tells me, 2.4, that is my coefficient. Alright, so that's a number between 1 and 10. And this number right here, the negative 2, that 2 is my power, that's my exponent. And that negative tells me which way the decimal moved. And the decimal moved twice. So that's where I count the number of places the decimal point must be moved. So the coefficient is the big number, and the exponent is the power. So we're going to do a couple practice ones. But what we have to remember is which way the decimal moves. So we talked about the fact that the number of places the decimal moves, or the number of times the decimal moves, equals the value of the exponent. And if the decimal moved to the left, then that means that I'm going to end up having a positive exponent. If the decimal moves to the right, when you're taking it out of scientific notation, then the exponent is going to be negative. The way that I remember this is if, like on this one, 800 is 8 times 10 to the second, this is a big number, okay? When it's a big number, I'm going to have a positive exponent. The reason it's 8.0 times 10 to the second is because there is an imaginary decimal right here, and it moved twice. So, when we have 0.0000343, right there, my decimal had to move 1, 2, 3, 4, 5 times. So that's where the 5 comes from. And I put the decimal immediately after the first 3 because that makes the the coefficient be between 1 and 10. So 3.43 times 10 to the negative 5th. Now, why is it negative when right here the the decimal moved to the right when I was putting it into scientific notation? So this rule up here, this has to do with when it is going into scientific notation. Alright, if you're taking it out, it goes the other way. So let's do a couple practice ones. So we're going to express the following in scientific notation. So if I look at this, it's 1,392,000 kilometers. So I'm going to assume if there's no decimal written, that there's a decimal at the end of the number. Okay? Mathematically, that's typically where your decimal is. So what I'm going to do is go ahead and right here, move the decimal 1, 2, 3, 4, 5, 6 times. I don't put it in front of the 1. I want it to be immediately after the first non-zero digit. So my my coefficient right here is going to be 1.392 times 10. And that's what it is in scientific notation. And right here I moved it to the left, and I moved it to the left 6 times. Since I moved it to the left, it was a big number. It's going to be times 10 to the positive 6th kilometers. If you notice, I dropped the zeros. That's fine. Drop those zeros. Okay? But that would be my answer right there. So let's look at the next one. On the next one, I want the decimal to move where it is going to go from where it is right now after the 0 to be between the 7 and the 5. So I'm going to move this 1, 2, 3, 4 times. My coefficient is going to become 7.5 times 10. I know it moved 4 times, but since I moved it to the right to put it into scientific notation, that means it was a really small number, so that means it's going to have a negative power. So negative 4 grams. So when you're putting something into scientific notation, you are going to know that you've got a positive exponent for a big number, for a number greater than 1, and you're going to have a negative exponent for a number smaller than 1. So now let's look at these other two down here on the bottom. Express these in regular notation. So if I've got 4.5 times 10 to the 4th centimeters, first off, times 10 to the 4th, that tells me it's going to be a big number bigger than 1. So if I want a big number bigger than 1, that means that my decimal is going to have to move to the right. Okay? So it moves to the left when you're going into scientific notation for a number bigger than 1. It moves to the right when you're taking it out of scientific notation. So 4.5 times 10 to the 4th, the way I do this is I rewrite 4.5, and then I move it 4 times. 1, 2, 3, 4. I fill in each of those little troughs with a 0, and then I rewrite it as 45,000 centimeters. Always write your units with it. Don't give me naked numbers. And then I've got 1.26 times 10 to the negative 3rd grams. So what I'm going to do right there is I am going to say, okay, I've got 1.26, and this number is going to be smaller than 1 because it's got a negative exponent. So I'm going to move that decimal to the left to make it a smaller number. So I'm going to take 1.26 and move it 3 times to the left. 1, 2, 3. And fill in, put a decimal right there. Put in those 2 zeros to fill in that trough. And I'm going to write a placeholder 0 right here, just to make life a little bit easier. It makes it look neater. And that's scientific notation.